Hi, this is Ms. Perez, and I'll be going over Solutions to Linear Equations tutorial. I'll be going over page 5 and page 17. Again, I know I'm switching around a bit, but I think it kind of helps get on with the rest of the tutorial. So if you haven't already done so, do assignment 1 and assignment 2, which is solving linear equations. And then the first tile and mastery test goes over creating those equations from words and then solving them. Here we're going to go over how many solutions a linear equation has and how to find that. So I'm going to start here on page 5, infinitely many solutions. I've highlighted the part that I think is most important and that I'll be putting in my notes. So I encourage you to read through this paragraph, pause the video if you need to. But it says there are linear equations in one variable that have infinitely many solutions or no solution at all. So here we can have a diagram, and this is kind of what I would put in my notes, so I'd have to write less. We have linear equations, which we've been dealing with, and solving. And now we're going to, and usually we would see when we solved it, we would have one solution, right? And that's pretty typical. But now we're going to see situations where there are no solution and infinitely many solutions and how to determine that. So let me go to my notes. So if you're following along as far as note taking and need some help, go ahead and write this down. We may have a real big title, Solutions to Linear Equations. I have the page number to reference. And then I have the little snippet if you feel like you need it. But otherwise, just have a little space left over right here because we're going to write something underneath from the next page. And leave enough space down here underneath your diagram so we can do some examples. Remember, math notes, we need lots of examples and explanations. So, go ahead and pause the video and set up your notes like this if you can. If it doesn't really fit horizontally like this, then you can write no solution and then underneath it one solution, infinitely solutions. Just leave space underneath it so we can do some problems. But I would set my notes up like this if it all fits and looks nice. Okay, so once you have that in your notes, go ahead and unpause the video and we will go to the next page, page 6. Actually, page 6 you're going to do on your own, and of course you're going to do great. Page 7. So this part I really liked how they said to determine whether an equation right here, to determine whether an equation has infinitely many solutions, solve the equation by performing opposite operations, which you've heard time and time again from me, apply properties of operations, and combining like terms. So that's a really great explanation of how you go about solving for a variable, those 3 kinds of things. So I would highlight it or put it in my notes, which I have. And again, go ahead and pause and read through the whole paragraph. Make sure you understand what they're talking about. But that's the most important thing that I feel like should be in your notes. So let me go to my next page. So this is kind of what your notes should look like as of right now. You have a couple little, snippets right here, and then you have your diagram. So once you have that, we shall move on. Yes, this is where I'm going to go ahead and skip ahead to page 16. And sorry for skipping around. I just kind of like how they condense the information into one page, and it's really easy to read. Okay, so here we have equation 1, which represents no solution. This is what it looks like if a linear equation has no solution. So after you've worked through the whole problem, done opposite operations, combining like terms, all of that, you're going to have a different number on each side of the equal sign. So here we can see it's 0 equals 2. 0 is never going to equal 2. So in that case, no number is going to satisfy this equation. So there's going to be no solution. So that's how you're going to tell if it's no solution, is if you have one number equal to another number. But I liked how they worded it here, a different number on each side of the equal sign. Okay, here we have equation 2, where it says same number on each side of the equal sign gives you infinitely many solutions. So same thing after you've worked out through the problem, opposite operation, combining like terms, you're trying to solve for x, and then you get a number equals itself. That is true. That is always true, right? 0 is always going to equal 0. So if you get that, if you get the same number on each side of the equal sign, then you have infinitely many solutions. So this could be very similar to what you would get on a mastery test, right? You could get 3 equations, and then your job is to, how many solutions does each one have? And this is how you go about doing it. Equation 3 is very similar to what we've been doing. They give you an equation, you solve for x, you get x equals 6. So if you get that variable that you're solving for equals a number, there's one solution. It's pretty normal, standard, solve for the variable. Okay, so all of this, same thing, pause the video, read through the paragraph, make sure you understand it. I'm going to take all of this and put it in our notes for us, and then you go ahead and copy, follow along. So here is where I'm going to fill in these. And actually, okay, so before I do this example with you, I kind of wanted to do a more basic one without fractions, simply because a lot of students, I feel, kind of, get a little crazy when they see a fraction and then they feel like they can't do it. And I don't want you to feel like that. I want you to feel like you can do this this type of problem, and that once you've mastered it, you throw a few fractions in there and it's still the same problem. So we'll come back to this exact problem, but I wanted to kind of throw a basic one at you. Okay. So here, let's go ahead and do the no solution one first. Go ahead and catch up in your notes, pause the video if you need to, or do one at a time. If spacing's looking a little tight, maybe just write one for right now, the no solution one, and we'll work through it. So I'm going to go ahead and scroll down so I have some room. Okay, so we're going to apply this right here. Solve the equation by performing opposite operations, applying properties of operations, and combining like terms. So we're going to do all 3 of those things. When I do that, I kind of look to see, okay, well, I have a variable on one side and variables on the other side, right? So let's combine like terms on, both sides, if we can, before moving anything. So I can see here there's a 6x here, and there's a minus 2x here. So I can combine these. So 6 minus 2 is 4. So we're going to get a 4x. And then the 5 doesn't have anything to combine with. It's just, a constant by itself. So we're just going to drop it down. Okay. And then over here, we don't have any like terms. Those are just, there's a variable and then a constant. So we can't really do anything. So let's just drop it down. There's nothing to combine on the left side. Okay, so now we're in a point where there's variables on both sides. Everything's combined. Now let's go ahead and move all our variables to one side. And if it helps you in your notes, let's say you're a student that really needs some detailed instruction, you can go ahead and write these side notes. This is, we combine like terms. Okay, so to do that, whenever we're moving pieces from one side to the other, right? We're not trying to just cancel them out, but we're actually physically trying to move a variable. So if you're trying to move a variable from one side to the other, you're going to use addition or subtraction. You'll never use multiplication or division, okay? So here we have a positive 4x, and I want to move it over, right? So I'm going to have the opposite of a positive 4x is a minus 4x. So I'm going to subtract 4x on both sides. And when I do that, the positive 4 and negative 4 cancel out, right? And then I'm left with 4x minus 4x, which is 0. They both cancel out, right? So after that, we're just going to bring everything that's left over down, and we get 5 equals negative 4. Now, 5 is never going to equal negative 4, right? So that would give you no solution. You have one number equal another number, and that's not true. Like, never it's going to be true. So that's what produces our no solution. So, have this in your notes. And then also in your notes, I would maybe, let's go ahead and try and copy this. I really like the way they said this. So I'm going to copy this over. Somewhere on your notes, go ahead and, put that little snippet. It might fit better underneath, for you. Maybe put it underneath. But go ahead and pause the video. Make sure you have this whole problem written down, how we solve for x, and then it came out, the x canceled out, and we have a number equal to another number, and that's what gives you no solution. Once you're caught up with that, we will move on to the middle one, which is one solution. So this is really similar to what we've been doing in the last couple, assignments. So same thing, we're going to solve for x using opposite operations. So I'm just going to put that for all of them. And then let's go ahead and do that, right? Okay, so first we're going to, again, combine like terms on each side. So maybe I'll add these in here, right? So I'll put it to the side. So we have a 3x that is a like term of x. And again, this might not be, very familiar if you've skipped assignment 1 and assignment 2. This could be a little difficult. So, definitely got to get your skills up with solving for a variable. And then this will be a lot easier. Okay, so when we combine them, this is 3x plus x. Now, if you have a variable with no front number, it is assumed to be an invisible 1. So this is 3 plus 1, which gives us 4. I'm going to get rid of the red. So this is a 4x now. And then the 7 doesn't have anything to combine with on that side. So we're just going to keep the minus 7. Equals, and then 5 doesn't have anything to combine with on that side of the equal sign either. So we're going to keep it there as well. Okay, and this one, move all variables to one side of the equal sign. We don't have to do that because lo and behold, when we look, all the variables are on one side already, so we don't need that one. But what we are going to do is we're just going to solve for x now using opposite operations. So let's go ahead and get my red out. So we look at minus 7, and the opposite is a plus 7. Plus 7. So when we do that, this cancels out. And what we're left with is 4x equals 79. That's 12. And then 4x, right, when a number and a letter are smushed together real close, we know that to be multiplication, right? So that's the kind of symbol for it. So this is 4 times x. The opposite operation of multiplication is division. So we're going to divide by 4, and what we do on one side of the equal sign, we have to do on both sides. So when we do that, the 4 cancels out just like how we want. Boom. And then what's left over is, I'm going to scroll down here a bit. What's left over is x equals 3. Okay, great. So we have a variable equals a number. So that's what indicates that we have one solution. So that's how you're going to tell if you have one solution. Now let's move to infinitely many solutions. So when I do this one, same thing. I'm going to first combine like terms, or I guess we could use this one again. This is kind of like an all-inclusive solve for x using opposite operations. And so when we do that, we're going to combine like terms first. So when I'm looking for my like terms, I'm looking, for the x's or the variable. And then, constants. But in this case, in all these cases, the constants weren't able to combine with anything. Now notice I circled the minus sign in front of the x. Because when you combine them, you have to consider what the sign is. So the sign of the variable is always going to be to the left of it. If there is no sign, like the 5, we're just we assume it to be positive. So when we combine these, again, there's no number directly in front of this minus x, so we assume it to be an invisible 1. So when we look at this, this is positive 5x combined with a minus x, right? So let me get another color, black. There we go. So 5x minus x gives us a 4x, because 5 minus 1 is 4. And then everything else just drops down because it can't be combined with anything else. Okay, so the next step is move all variables to one side of the equal sign. So let's go ahead and do that. So I can, I want to move this positive 4x over. And again, when I move variables from one side to the other, I'm going to use addition or subtraction, whichever is the opposite. So since this is a positive 4x, the opposite is a minus 4x. And what I do to one side, I do to both sides of the equal sign. And when that happens, they both cancel out, right? 4x minus 4x gives me 0 on both sides. So what I'm left with is a 4 equals a 4. Okay, so here's where we're going to have infinitely many solutions, and the verbiage that they use, or the wording that they use, is same number on each side of the equal sign. That will produce infinitely many solutions. So let's go ahead and write that in our notes. But hopefully your notes look something, similar to this, okay? Where we have, our title, our diagram, and then 3 examples of each one, right? So I think the examples are really going to help you in your mastery test, because this is really similar to what you would see in a mastery test. They'd give you some equations, and you have to decide, okay, do they have no solution, one solution, or infinitely many solutions? So definitely have these in your notes. Pause the video if you need to. In the next video, I'm going to go through the actual problems on page 16, which that have fractions. So those of you who need help with your fractions, that'll be the next video. And then we will practice page 17. Okay? All right. Well, hope this video was helpful as always, and I'll see you in the next one. Bye.